In this section, we're going to cover Unit 3A and a little bit of 3B as well, which talks about the sine and cosine graphs, and in particular to start with the amplitude and the period. Okay, so just as we had turning points and x-intercepts and y-intercepts to graph our quadratics and our cubics and our linear functions, to graph a sine or cosine graph, we need an amplitude and a period. So we're still graphing, we're just finding different points in order to graph. So you'll see this in front of us here is from your formula sheet. So we're on the third page, we're right down the bottom at the end of the trigonometry section. There's also the tan graph next to it, which we'll go through in the next video because it's a bit different. But sine and cosine are nearly identical with how we treat them. They just start from different points. So you can see here sine graph starts at the origin and goes up and back through, whereas the cosine graph starts up. So it starts at the top of the amplitude, which will make more sense in a minute, and it drops and comes back. So let's talk about these two things, amplitude and period. So the amplitude is the distance between the average, which is the line in the middle. So here you can see that the average is on the x-axis, okay, or it's 0. And you can see for these ones too that it's on the x-axis. So the average there runs right through the middle. The amplitude goes from the middle to the furthest point. So here it goes from the middle to the highest point. Here it goes from the middle to the lowest point. So the amplitude tells us how far up and down it's going to go. So you can see there, it just goes up to the same point, in this case 1, down to -1, up to 1, down to -1, up to 1. So that's an amplitude there of 1. If we change that to an amplitude of 4, it would go up to 4, down to -4, back to 0, up to 4, and it just changes how high it goes. Doesn't change anything else, doesn't change where it cuts the x-intercept, just changes how far it goes and how steep it is. So that's our amplitude, the distance between the average and the highest and lowest points. The period tells us how long we have to go before the graph repeats itself. So if we look here on the sine graph, it starts at the origin, it goes up to the amplitude, cuts down, back. That is one kind of lot of sine. It then repeats itself. So in this case, that's another period. Okay, so the period, it happens, it goes dip, 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 stops, repeats. Okay, and that will go on and on forever unless we restrict the domain. So the period is one lot before it repeats itself, and we can see there that apart from when it hits the x-axis, there's no kind of, well, repeating, for lack of a better word. We've got a maximum there, hits, minimum, back to it. So in this case, for sine, the period is 2 pi because it repeats itself every 2 pi. With this cos graph here, we start here. We want to go back before it starts repeating itself, so we stop there. So that's one period. And that's another period. Okay, so in this case, again, if you look at the yellow, it goes from 0 to 2 pi. So its period in this one is 2 pi. Okay, we can see here, this is a sine graph because it starts from 0, goes up, down, stops. So that's got a period of, I think that's a 6 there, maybe a 7, not very clear in that one. And then it does the same here. So it's going to repeat over and over and over and over and over again. And what will normally happen is they'll ask you to graph it to a certain point, or they'll ask you to graph it for 1 period or 2 periods, and you've got to figure out where that sits. So now we know a little bit about what we're looking at. Let's try and actually figure it out. So from your formula sheet, you're given the sine and the cosine graphs, and you're given kind of the standard what it will look like here. Now remember how I told you about that average? So the average going along the middle here? We can move that. And we can do that by adding like a plus b here. So if we go plus 4, the average will move up to 4, and the graph will go off that. But as it's not on your formula sheet, you can take that as a pretty big hint that the average is normally going to be at 0. So it's going to look just like that. Just be aware if you see a plus 2 or a minus 3, you're going to move the average down to plus 2 or minus 3. So let's have a look at the information we've got here. Let's get rid of all that. Let's start with the sine graph. So we've got y equals a sine of nx. So the a tells us the amplitude. Okay, so the number out the front tells us how high we're going. Okay, and in this case it's 1. The n tells us how far we're stretching that period over. So in this case, it's 2 pi. Okay, so pretty simple. There's a little bit of backtracking if you're trying to find an equation, but we just need to know those two things. Amplitude is a, the period is 2 pi over n. That's not very clear there, so check your formula sheets that it's readable, because this is off the task website and it's not very clear. So 2 pi over whatever n is, and n is a number in front of the x. So let's give it a go. So I've got here your exercises for 3A and B, and question 1 asks you to state the period and the amplitude for each of the following functions. So if we have a look at A, first what we're trying to do is figure out, is it a cos graph or is it a sine graph? So it starts from the origin. Okay, so it's a sine graph. Now this here on our formula sheet shows us that one period on the sine graph goes up, hits, down, hits. That's one period. So we're going to find one period on this one. Going up, hit, down, hit. So we get through one period in 4 pi. Okay, so our period there is 4 pi. How you should be thinking about it is 4 pi minus 0. Okay, because it won't always go from the origin. It might go from somewhere else, for example here. Okay, so you go one end, take the other end. First one's a bit nice for you. The second thing we need to do is we need to state the amplitude. Okay, so the amplitude is the distance from the middle up. So from the middle up and the middle down. So the highest it goes is 2 and the lowest it goes is negative 2. So it never goes further than 2 units from the middle. Okay? So our amplitude is 2 and our period is 4. Gonna see if we can do a little bit trickier one. This one down here may be E, just because it doesn't go off 0. So we want to find the amplitude and the period. So let's do the amplitude first because it's easy and we can get points there even if we can't figure out the rest of it. So the highest that the graph goes is 2 away from 0, so our amplitude is 2. Okay, so the furthest away it goes from the middle of the graph is 2. Now we want to find the period. So we're looking at a sine graph. We want to go up, hit, down, hit. So we need to find the distance between those two, and we can do that by inspection, or we can do it by taking the taking the left-hand side one away from the right-hand side. So we can go pi, take negative pi, which is 2 pi. So our period there is 2 pi. So each 2 pi, our sine graph will repeat itself. Let me find a cos one. Let's do this one up here. So this is a cos graph. And I know that because it starts away from the origin or away from the middle of the graph. Okay, it's starting on 3. So we're going to do the same thing. We're going to look for the amplitude, so the highest point that it reaches, which is 3. Okay, pretty easy. But we also need to look for the period. So if we go back to our formula sheet, a period for the cos graph starts up high, goes down low, and then goes back up high. So starts up high, goes down low, back up high. And they haven't told us this endpoint here. Okay, what we do know, sorry, trying to color coordinate this. What we do know is that it goes from negative pi on 3 to pi without repeating itself. Okay, so we need to find the distance between those two. So we need to find out what pi take negative pi on 3 is. So a bit of fraction work there, so it's pi on 1 plus pi on 3. So we can turn this into 3 pi on 3, 4 pi on 3. Okay, so our period there, oh terrible, is 4 pi on 3. Okay, so if you've got a graph like that that goes past 0, you can kind of look at it almost like you look at the sine graph, that we're looking for where it doesn't repeat. Otherwise, you might be given information from 0. If we had another point there, we could have found the period that way as well. So I hope that clears up a little bit about periods and amplitudes. So that's from our graph. We also need to be able to find the period and the amplitude from an equation. So let's have a look for an equation here. Okay, we'll do an easy one and then a hard one. So we'll start with 2 sine of 2x. Sorry. Down here, we're going to do this one. So I'm going to have a look at my formulas. It's a sine graph. So I'm looking y equals a sine of nx. So a is my amplitude. So a here, okay, so my amplitude is 2. Okay, pretty easy points to get the amplitude. I also need to know what the period is. So the period is 2 times pi over n. And n is the number in front of the x. So 2 times pi over n. N is the number in front of x. So 2 pi over 2, which is pi. So my period is pi. So that means when I graph it, let's say that that's pi there. It's going to go jup, jup, and it's going to stop that one repeat at pi. Okay, so that was quite a nice one, mainly because they're whole numbers and they work out quite nicely. So let's try one that's not quite so nice. Okay, now there's an easy part to this and there's a bit of a more difficult part to this. So the easy one is the amplitude. Once again, it's just a number out the front. So my amplitude is 2.5. The harder part is the period. So we want to find the period by 2 pi over n, which is fine in the last one, but this time n is pi over 4. Okay, we kind of ignore the x and we take the rest of the term. So it's pi on 4. So we can write it 2 ways. We can write it as 2 pi divided by pi on 4. Which will confuse the bejeebers out of most people, including me. So I suggest you write it as 2 pi divided by pi on 4. Okay, you don't want to put fractions over fractions unless you're feeling very, very confident. So how do I divide these fractions? Well, I make them both into fractions. I flip the second one and I change it to a times. So now I've got 8 pi over pi. My pi's cancel out, and my period is 8. Okay, so every 8 units, let's say this is 8, every 8 units my cos graph is going to repeat. So it's going to go something like that. Okay, so we've kind of covered amplitude and period. Now all we have to do is bring it all together and actually graph it ourselves. So we can do that a bit further down here. Let's try a bit of a difficult one to practice those fraction skills. Let's go G. So we're going to find the amplitude, the period, and then we're going to use it to graph it. Okay, so the first one, amplitude's pretty easy to find. Number at the front is 5. The period, got a fraction, so again, we're just going to kind of ignore the x and make that a 1. So we've got 2 pi over n, which is 1 over 3. Turn that into a 1. Tip and times. So we've got 6 pi. So that means that one sine, so one of these, that was terrible, one of those will take 6 periods to complete. So let's draw it. So we're looking at a line. We're not looking at quadrants. We're not looking at circles anymore. We're looking at a line. And this line is 6 pi long. Okay, so the amplitude, the highest this graph reaches is 5, and the lowest it reaches is -5. And we know that the sine shape looks something like that. So I'm going to put a mark in the middle, and that's where I'm going to cross over. And I'm going to put a little mark as well to tell me kind of where to turn. So start at the origin, turn, cut through, and back. Okay, so I'm nearly all done with my graphs. They're quite simple once you've got the amplitude and the period. I've just got to label some other points. So I normally label where it cuts through. So that would be half of 6 pi, which is 3 pi. And if you want to as well, if it's not going to cause too many issues, you can label a few other ones as well. What have I done? That'd be 4.5 pi. Okay, let's not label those ones. It's going to take too long. All right, so one that cuts through or one halfway through will be fine, but make sure your end is labelled, the end of your period, and your amplitudes are labelled as well. The only other thing we need to be able to do is try and find the equations when we're already given the graph. Okay, and we can do that by thinking about what is the amplitude, what is the period. So this one here, my amplitude, the highest it reaches is 1.5. So I know automatically that it's going to be 1.5 something of something x. Okay, I'm going to look at the shape of the graph. It starts at the origin, so it's sine n of x. So now I've just got to figure out, well, what is n? And I do that from finding out what the period is. So the period is 3 pi. The problem is that 2 pi over n gives us the period. Okay, so I can't just put 3 in there. Don't make that mistake of just going, oh yeah, it's 3, and popping it in there. You've got to figure out 2 pi divided by what gives me 3n. So 2 pi divided by what gives me 3 pi. Okay, the easiest way I think to do this is put 2 pi over 1 and try and think if we're multiplying, where everything's going to go. So I can't think of a way to turn 2 into 3, but I can think, well, if it was 6 pi over 2, then that would give me 3 pi. Okay, so we almost need to go bigger numbers. So if we were going to make this times, what would I want it to be? Well, I'd want to get the top to be 6 pi, so I'd times that by 3. and I'd want the bottom to be 2, so I times that by 2. And because we're talking about divide, that's going to go upside down. Okay, I'm going to check my answer. I've made a guess almost. I know it's going to work, but I've made a guess. And then I'm going to check it. So 2 pi divided by n, we're saying n's 2/3. We're going to flip the second fraction. Hope I've actually flipped it. Which equals 6 pi over 2, which equals 3 pi, which is our period. Yes. So n is 2/3. That there, finding the period, especially when it's a fraction, is the hardest part of graphing sine and cosine graphs. Okay, the other parts, like finding the amplitude and things like that, are quite easy. It's that last bit that gets really hard. So what I would suggest is you write it out like I did, divided by what gives me 3 pi. Okay, and a little bit of guess and check, but make sure you actually check. You don't just guess and pop it in. So I hope you have a bit of an understanding now of what sine and cosine graphs look like and how we can graph them and how we can get information from them. Okay, so the formula sheet has most of it there for you, amplitude, period, and the sine and the cosine examples. So have a go at those exercise sheets and good luck.